You know when your day just seems to drag on forever, but your friend has a great day, they just sailed through. When this happens, you're experiencing different perspectives of time while observing the same 24 hours. You travel through time at different speeds. Another way we commonly are mixed up with time travel is when we look up at the night sky. The light we see from the stars is actually from many light years ago. We are looking directly into the past. Time dilation is our third example of time travel. It means a difference in elapsed time as measured by two clocks. An example of this is if a person was standing on a train platform and someone else was standing in the train while the train is moving and is equally between two trees. A bolt of lightning hits both trees at the same time. The person on the platform would see simultaneous strikes. However, because the train is moving towards one tree and away from another, the person within sees the bolt in front first and the bolt behind after. This is one of Einstein's thought experiments and allowed him to conclude simultaneity is not absolute. Therefore, time is relative. This leads us on to Einstein's theory of special relativity, published in 1905. It is an explanation of how speed affects mass, time, and space. The theory includes a way for the speed of light to define the relationship between energy and mass. The famous equation E is equal to mc squared, where energy is equal to mass multiplied by the speed of light squared. However, in 1915, Einstein publishes his theory of general relativity, where he claims space and time are the same. Together they form a four-dimensional fabric or continuum called space-time, upon which the events of the universe unfolded.
There are many reasons why time travel is often portrayed wrong in movies, and many problems we would need to overcome if it did exist. If you have a time machine, you wouldn't just need to move through time, you'd need to move through space as well. It is usually assumed that if someone is traveling through time, he or she will land in the same place as where they left, past or future. But we have to remember the Earth rotates around the Sun at a speed of 110,000 kilometers per hour. The solar system itself is moving in its trajectory around the galaxy at a speed of 750,000 kilometers per hour. If we time traveled for even a few seconds while staying in the same coordinates, we would probably find ourselves floating in outer space. Our time machine will have to take into account this movement of the celestial bodies and place us in the exact right spot in space. Another massive problem of time travel are paradoxes. A paradox is a statement that is self-contradictory or opposed to common sense. One of the most famous examples of this is the grandfather paradox. In this, you need to imagine that you have a time machine, and for some reason or another, you decide to go back in time and kill your grandfather. Because of this, your grandmother never gives birth to your parent, who then in turn never gives birth to you, meaning you couldn't have killed your grandfather. Confusing, right? There are endless paradoxes, problems, solutions, equations, books, movies, TV shows, and more regarding time travel and how it works. We hope that you've learned a little bit more about the complex enigma that is time travel from this video.